All right, we now begin the final 2 chapters of this semester. Are they hard? Parts of it is hard. Parts of it is challenging. Not today, not tomorrow, but parts of it is challenging. Okay? What we're going to do is we're going to learn. We got all the pieces now in place. So we're going to take our understanding of chemical formulas and now be able to describe chemical reactions using chemical formulas. Next chapter, we're going to add math to what we do this chapter. Okay? So we'll piece it all together. Your last tests of the 9 weeks will basically piece together 18 weeks of work for us, which is extraordinary. All right. If given the chemical names or formulas for a chemical equation, I can correctly balance the equation. You've done this before in middle school. Okay? That part, the balancing is not hard. There are a few that are hard. Mostly they're not hard. Here's what makes it hard. Did you notice what I'm asking you to do? I'm asking you to take the chemical names and balance the equation. In order to balance the equation, what are you going to have to convert the chemical names to? And some of you still are not very good at it. So the problem with this is not the balancing equation part, it's the problem that I warned you about a month ago. If you don't know how to write chemical formulas, you're in big trouble. Everything builds on it. All right, let's begin by me telling you that methane gas reacts with oxygen to produce a blue flame that you see here, and it produces carbon dioxide and dihydrogen monoxide. Those are words. And they very accurately describe what exactly is going on. But it's using words, and it takes time to write all that down. If you're artistic, you could do it this way. Methane you can represent with a little ball and 4 pimples to represent the hydrogens. And then the 2 red behinds there. And they become carbon dioxide, which is represented by kind of like an Oreo with red cookies and a black filler stuff. And then 2 upside down Mickey Mouses. If you're an artist, you're going, yeah, I would love to do this. Most of us are going, no, that would be bad. Okay, so there is yet another way of describing chemical reactions. This way. CH4 plus O2 yields CO2 and H2O Okay? What's wrong, Simon? Okay. All right. You like that way? No? You would prefer to draw it?
Yeah.
Okay. You prefer to use names? You know what? Your preference really doesn't matter to me because this is the way we're going to do it. The advantages to doing it this way are shorter, more succinct, easier to read, faster, and it doesn't matter what language you write in. When it comes to writing a chemical equation, everyone will write the same way. Whether you're in China or Spain or America, you're going to use chemical equations that you saw there. Now, in order to understand this concept of balancing equation, you're going to have to understand why we have to balance equations. And the why comes from the most important law in chemistry, the law of conservation of matter. Okay, who can once again tell me what the law of conservation of matter is? Phoebe.
It means that you can't destroy or create matter. It just goes from
From one form to another. I wouldn't say state. Yes. Okay, and who said it? First name is Tony. Anybody? Tony Lavoisier. Antoine Lavoisier. Of course you've heard it. I've showed you an animation of it. Remember? He's the one that had a wife that... he's the one that during the French Revolution lost his head because he was really rich. Okay. Now, question. Does this equation obey the law of conservation of matter? Molly, yes? Let's see. What do you mean no? Matter has been lost. What else?
There's an extra oxygen here.
There's 2 and 1 more here. That's 3. And how many here? Matter has been created. Is that okay, Ms. Marino, as long as you create and destroy at the same time? No, it's not good. No. Okay. No. You can't do it that way. So, we say that the reaction is unbalanced. We use coefficients in order to balance it. What are coefficients? Coefficients are numbers. It's like how many packages of each thing you need in order to balance it all out. It's big numbers that you place before a formula, saying that you have that many number of things. In an equation, typically if you don't see a number, there's a number there. That number is 1. Understood once. Okay. Now, there are some rules that are probably important rules for you to record. So I'm going to give you a few moments to write these things down. Okay. First of all, move from left to right, unless you're an Asian, in which case you're more comfortable going from right to left. Sasquatch, that's up to you, man. Try to make any odd numbered even. You'll see what I mean. Water, best to characterize it as HOH instead of H2O. You'll see what I mean. Keep polyatomic ions the same. Keep them together. Keep them as a unit, unless they are split apart. If they're split apart, you have no other choice. It's easier just to keep them together. You'll see what I mean. Double check your work, because sometimes in your efforts to fix something, you may have actually unfixed something that was previously fixed. And above all else, please, Elizabeth, make sure your formulas are correct, because if they're not, you're dead in the water. Yes?
Are there sig digits on this?
No. All right. Alec, in order to prove to you there are no sig digs, balance this equation. How many C's? How many C's? Ka-ching! Good start. How many H's?
4.
Alec. How many H's? Now, some people are going to go, hey, well, let's just change that to a 4. No! You can't do that, gang. There are numbers here. If you don't see a number, it's an understood 1. That's the only thing you can change. So, Alec. Now, how many H's?
4.
That's right. How many O's? Be careful, there are 2 O's spread out here. There's 2 right there and 2 right there. Remember, if you've got 2H2O, you have 4 H's and 2 O's. You got to distribute the whole thing. Okay, so we have 4 O's on this side. We only have 2 O's on this side. How do we fix it? Let's go back and check. How many C's?
1.
How many C's?
1.
How many H's?
4.
How many H's?
4.
How many O's?
4.
How many O's? Success! Elizabeth. How many NAs? How many NAs? How many BRs? How many BRs? Fix it. Can we put a 2 right there? Would that help? No. Can't do that. Can't do that. Can't do that. If you need a BR, you're also going to have to get a 2NA. Okay? It has to go in front of the whole thing. 2NA BR. Okay, so now the BRs are fixed, right, Elizabeth? How many CLs? How many CLs? Fix it. But now you've messed up your NAs. Or have you? Let's see. Elizabeth. How many NAs? How many NAs? How many BRs? How many BRs? How many CLs? How many CLs? Now I want you to notice 2 very important things. When I translated these chemical names into chemical symbols, I encountered chlorine. How did it become Cl2? Are we still on that? Okay, gang. Anything I teach you will come back around constantly. Okay, so asking, are we still on that? Yes, we will be on this until May 31st when you take the final exam. Okay? Unlike all your other classes, chemistry builds on itself. Okay? So, be very careful. Here is another one. So, when you get to these things, like questions 5 through 10 on your homework, what I would always do is look for the diatomics first in order to remind myself that they need to be changed to their diatomic form.
So,
Any brother Huncliffe has to go down as a twosome.
okay, so it doesn't matter that one's a gas and one's a liquid.
It's in their natural form. In the case of bromine, its natural form is liquid.
Okay.
In the case of most of the others, they're gases. Iodine's going to be a solid.
Okay.
All right. Here's a little hell bender. This is as hard as they get. Who on that side wants to tackle that? No, that side. It's that side. All right, Noah. Aluminum sulfate. Remember, you're going to screw everyone up in this class if you don't write correct chemical formulas. All right, charge on aluminum. Charge on sulfate, 8. What is the chemical formula? Are you sure? Because it's going to screw everything up. All right, then. Calcium chloride. Calcium. Symbol. Chloride. Formula. Are you sure? You're going to embarrass yourself if you're not. All right. Aluminum chloride. Yeah. Oh, I'm sorry. Let's start. Yeah. Al plus 3, Cl minus is AlCl3. And calcium sulfate. Ca, charge. Sulfate. Okay, what I want you to notice is that we are dealing with at least one polyatomic ion here, aren't we?
Yeah.
Ask yourself the question, is it staying a polyatomic ion? Yes. Okay, so circle it and keep it a unit. Keep it one unit. It makes things a whole lot easier than splitting it up into sulfur and oxygen. In other words, don't call this 3 sulfurs, 12 oxygens. Call it 3 SO4s. Understand?
Yeah.
All right, Noah. How many ALs?
2.
How many ALs? Fix it. How many SO4s? How many SO4s? Fix it. How many CAs? How many CAs? Fix it. How many CLs? How many CLs? Ka-ching. Let's go back and make sure that we've not screwed anything up. How many ALs? How many ALs? How many SO4s? How many SO4s? How many CAs? How many CAs? How many CLs? How many CLs? Congratulations. That's as hard as these get.
Do you have to like rewrite it down with the plus 3 CA?
Nope. All right. Do 8.1a.